So now that you know how to solve exponential functions, it's only natural that next we look at solving logarithmic equations. So when I'm solving logarithmic equations, there's going to be two separate paths that I choose. I'm either going to choose, is it log equals log, and therefore I should set whatever I'm taking the log of equal to one another and solve from there, or is it log equals a number, and I should therefore choose to change it to exponential form and solve from there. I'm going to do two separate videos. Each video will have 3 examples. They are long. This tends to be a difficult section for students, not only because it's new material, but also because it really requires that you have a strong background in solving equations and you have a bag of tricks that you can kind of pull from. So if you feels like you understand it and you just want to watch the first video, please just watch the first video. If it seems like it's difficult for you and you're struggling to understand it, please also watch the second one. If you want to take a break before you jump into the second one, do that. But looking at these 3 examples, we want to first determine, is it log equals log or log equals a number? Please keep in mind that oftentimes you will have to manipulate your equations a little bit to get them into one of those forms. So the first thing I see when I look at example 1 is I have a log expression, another log expression, a number, and another log expression. Well, that pushes me to believe that this is going to be a situation where it equals log equals number. Because no matter what I do to manipulate this with my properties, it's going to be extremely hard for me to force a log. In fact, it's going to be impossible for me to force a log onto the 3 and have this still be solvable. So, because I want to change it to log equals a number, I'm going to pull this to the other side by subtracting it from both sides. When I subtract it from both sides, I will have log base 2 of 2x squared plus 1 minus log base 2 of x plus 1, what I was given, but now I'm also going to be subtracting a log base 2 of x minus 1. That will all now just equal 3. So I want it to be a single log equals a number, so I'm going to go ahead and say I want to put these together. Well, I know if I factor a negative out here, then I'll be able to use some properties. So log 2, factoring out a negative, that now becomes plus. I'm going to take these properties, I'm going to put them together in 2 steps. I'm going to go ahead and say I can put these together and multiply the x plus 1 and the x minus 1, and then put that in itself together with this and make it a division problem based on this subtraction. Please let me know in class if that doesn't make sense to you. Star that, highlight it, whatever is going to work for you, so you can bring that with you to class and I can clear that up for you. Okay, so now according to my steps above, now that I have log equals a number, I'm going to change this to exponential form, giving me 2 cubed equals 2x squared plus 1 over, I'm going to anticipate that I'm going to have to FOIL this out at some point anyway. So using my formula a plus b times a minus b, I get x squared minus 1 squared, which is 1. So now that I can have this, now I'm going to go ahead and solve it. So I'm going to scoot this over a little bit to give myself some more room. And I'm going to bring this, bring this up here. 2 cubed is 8. I know that this is a situation where I have a rational expression. I know that we've studied rational expressions before, and I can solve them by cross multiplying, giving me 8x squared minus 8 equals 2x squared plus 1. Notice that I was careful to make sure that when I cross multiplied, I did multiply the 8 by both of those terms. I see that this is a quadratic equation, and there's only an x squared term, so I'm going to get x squared by itself so that I can take square roots. So let's see, I'll subtract x squared, and I'm going to add the 8, giving me 6x squared equals 9. Which means x squared equals, I can reduce that, 3 over 2, which means x equals plus or minus the square root of 3 over 2. Well, I have to now check my answer because I could have an extraneous answer because I know that the domain, I'm going to put that up here because I don't have a lot of room down there, the domain of logs is that x has to be greater than 0. Think about that graph. I cannot plug any x values in that are less than 0 and be able to take the logarithm of them. So if I check to see if this works, all I'm going to do is take the positive square root of 3 over 2 and check, is 2 times the positive square root of 3 over 2 squared plus 1 greater than 0? And it is, so that checks. Is the positive square root of 3 over 2 plus 1 greater than 0? Yep. Is the square root of 3 over 2 minus 1 greater than 0? I can check that with my calculator, and it is. So then now I'm going to do that same thing with the negative square root of 3 over 2. And again, I can use my calculator for assistance. So I check, is 2 times the negative square root of 3 over 2 squared plus 1 positive? Yep. And greater than 0. Is the negative square root of 3 over 2 plus 1 greater than 0? And it's not. I check it with my calculator and I get a negative answer. So even though I got that as a solution, it is extraneous. And my only answer for this is x equals the square root of 3 over 2. Okay, looking at my next example. Again, I'm first going to ask myself, is this log equals log or log equals a number? Well, I see I have a number here, but this time, unlike the last time, it's actually attached to a logarithm. So since every single term contains a log, I'm going to go ahead and say that this is going to be a situation where I have log equals log. So I'm going to, again, use my properties to make that look that way. So I'm going to combine these two using division, and I'll have log of x squared minus 4 over x plus 2 equals, I can put the 2 up here, log of x minus 2 squared. Now that I have it in the form I want it to be in, I'm going to go ahead and I'm going to take and set each of these equal to one another. So I'm going to have x squared minus 4 over x plus 2 equals x minus 2 squared. So notice in the last example, as I said before, we're going to have kind of a bag of tricks to pull from. And in the last example, I had to be able to solve rational as well as quadratic equations. Here, I'm going to notice that this could be simplified. I know that this can factor to be x plus 2, x minus 2, and then my x plus 2's can cancel out. So x plus 2, x minus 2 all over x plus 2. Those cancel out. I'm going to go ahead and FOIL this. I can FOIL very quickly in my head. X squared minus 4x plus 4. And now I have x minus 2 equals x squared minus 4x plus 4. Once again, I have a quadratic equation. I want to get it equal to 0. So I'm going to subtract x and add 2 to both sides, giving me 0 equals x squared minus 5x plus 6. I can solve this quadratic equation. Last time I solved it with square roots. This time I'm going to solve it with factoring. And I get 0 equals x minus 3 times x minus 2. Therefore, x must be 3 and x must be 2. I check to make sure neither of those puts a 0 or less inside of my logarithm. 3 squared minus 4, I'm good. That's above 0. 3 plus 2 above 0. 3 minus 2 above 0. This one works. It's a good solution. When I check 2 squared minus 4, that's going to give me 0. I cannot take the log of 0. It is not part of the domain. So I'm going to go ahead and say that this does not work by putting a does not equal to line through it. Looking at one final example, I'm going to do the same thing. Oh, and I forgot, I need to change this. So you'll have to change it in your notes as well because this is the same as the example above, the first one. So I have this changed to be log of 5x plus log of x minus 1 equals 2. So I see that because this 2 doesn't have a log attached to it, I'm going to assume this is going to be a situation where I can get log equals a number. So I'm going to go ahead and put these two logs together. It's adding, so my property tells me I can multiply. Then I can say, oh, now that I have log equals a number, I'm going to go ahead and change to exponential form. So if there's no base written, it's 10. So I get 10 squared equals 5x times x minus 1. If I want to solve this, it would be helpful to distribute, so I have 1x instead of 2. So I'm going to go ahead and say 100 equals 5x squared minus 5x. And now I see it's quadratic, so I'm going to get it equal to 0 again by subtracting 100. I notice that I can factor out a GCF of 5. And I see I can factor this further because I know that negative 5 times 4 is negative 20 and negative 5 plus 4 is negative 1. So I get 0 equals 5 times x minus 5 times x plus 4. 5 will never be 0. 5 will make this 0, and negative 4 will make this 0. So I'm going to say x is 5, x is negative 4. The last thing to do is check those. If I plug 5 into my original problem, yep, that's bigger than 0. Yep, that's bigger than 0. If I plug negative 4 in, nope, that's not bigger than 0. Therefore, x does not equal negative 4, and it only equals 5. So once again, there are a lot of steps to these. It takes a lot of new steps as well as a lot of old steps. There's a big focus on how strong are your solving skills. If you would like to see some more problems like this, please watch the next video. I have 3 additional examples that are going to be similar yet different to these. And then make sure that anything that you were not understanding or had questions on that you do bring with you to class.